In this video, we are examining the concept of bond energy. At the most basic level, chemical reactions consist of breaking and forming bonds between atoms. The breaking of bonds requires energy to be added to the system. This process can therefore be considered an endothermic process. Conversely, the process of forming chemical bonds results in the release of energy, making this an exothermic reaction. So far, we've used experimental means such as calorimetry to measure the enthalpy change of certain reactions. By quantifying the enthalpy change for the breaking and forming of different chemical bonds, we can predict the change in enthalpy for a reaction in a non-experimental way. As the simplest possible example, let's look at the dissociation of molecular hydrogen into elemental hydrogen. This equation shows that 1 mole of molecular hydrogen dissociates into 2 moles of elemental hydrogen. In examining this reaction, we see that it requires the breaking of a single hydrogen-hydrogen bond. Upon looking up this in the table, we see that to break 1 mole of hydrogen-hydrogen bonds takes 436 kilojoules of energy. This is the bond energy for hydrogen-hydrogen bonds. In this case, we're dealing with a single mole of hydrogen-hydrogen bonds. If we were to double the number of moles of molecular hydrogen to 2 moles, we'd also need to double the change in enthalpy to 872 kilojoules. When working with diatomic molecules and other simple chemicals, it's possible to experimentally determine the exact bond energy. However, with more complex molecules such as hydrocarbons, we have to deal with the average bond energy. Take as an example the complete dissociation of methane into its constituent atoms. As you can see from this structure, this is 1 carbon surrounded by 4 hydrogens. This means that there are 4 carbon-hydrogen bonds. The bond energy of 1 mole of carbon-hydrogen bonds is 414 kilojoules. Dissociation of 1 mole of methane requires the breaking of 4 moles of carbon-hydrogen bonds, making the total enthalpy change for this reaction as 1,656 kilojoules. So far, we've looked only at dissociation reactions requiring the breaking of chemical bonds. Most reactions, however, require both the breaking and the forming of chemical bonds. In our next example, we'll look at the formation of ammonia from nitrogen and hydrogen gas. From this chemical equation, we see that 1 mole of nitrogen gas combined with 3 moles of hydrogen gas makes 2 moles of ammonia. When examining the structural formula, however, we see that on the reactant side, this requires the breaking of a single triple nitrogen-nitrogen bond and 3 single hydrogen-hydrogen bonds. On the product side, it requires the formation of 6 nitrogen-hydrogen bonds. To calculate the enthalpy change for this entire reaction, we deal with the reactants and the product side separately. In terms of the reactants, a triple nitrogen-nitrogen bond has a bond energy of 945 kilojoules per mole. A hydrogen-hydrogen bond has a bond energy of 436 kilojoules per mole. The reactant side of this equation requires the breaking of a single mole of triple nitrogen-nitrogen bonds, requiring 945 kilojoules, and 3 hydrogen-hydrogen bonds, requiring 1,308 kilojoules, giving a total of 2,253 kilojoules for the reactant. When looking at the product side of this reaction, we're forming 6 moles worth of nitrogen-hydrogen bonds. The bond energy for this is 391 kilojoules per mole. In performing these calculations, it's important to realize that the formation of a chemical bond is an exothermic event. As a result, the bond energy for this reaction is negative 391 kilojoules. As we are forming 6 moles of nitrogen-hydrogen bonds, we multiply this value of negative 391 kilojoules by 6 to give negative 2,346 kilojoules. To calculate the total enthalpy change for this reaction, we simply add the enthalpy changes for the reactant and the product sides of the equation. On the reactant side, we saw that the breaking of bonds required 2,253 kilojoules. On the product side, we saw that 2,346 kilojoules was released by the formation of bonds, giving a total enthalpy change of negative 93 kilojoules